the session. This morning, Shanpreet showed you how to create a document, a PDF document from scratch using iText objects such as paragraph, text, table, cell, list, also using low-level objects. Now, there's a big advantage to create PDF this way, and the advantage is that everything is programmable. So you can configure your documents exactly the way you want to. I'm going to give you an example. There's a car manufacturer, and for every car that leaves the plant, there's a 20,000-page PDF document that has the complete information about that car. So it has blueprints, and if you click on the blueprint, you go to a page that has like a bigger version of the blueprint. You click on an object, and you go to a page that has the description of this object. So this is a highly configured document that is created from scratch using source code. There's a big disadvantage to it. The disadvantage is that every time a small change is needed, like if you would create an invoice like this, and someone says, can you move the logo like half a centimeter to the right, and can you make this part of the header a little bit smaller? If you want to change something like that, you need a developer to change the source code. So that's the disadvantage of this approach. Then Shanpreet also showed you how to use an existing template. For instance, Acroform technology, you have a form, everything is fixed, and you just fill out the fields. The disadvantage, so if you would use this for invoices, the disadvantage is that you would create a template, for instance, with 20 invoice lines, and then if an invoice only has 10 invoice lines, you fill out the first 10, and the following 10 are blank. That may be acceptable. But if an invoice has like 25 invoice lines, you can only fill out 20, and then you have to add an extra page, and then see where do I add the next 5. So that's not impossible. There are people who use Acroforms for this, but that's a disadvantage. You also have XFA technology that's dynamic in the sense that XFA, a document that is created with Adobe Lifecycle Designer, Adobe Lifecycle Enterprise Suite, that's actually not a real PDF. That's a PDF with XML inside. And it's the XML that is rendered in Adobe Reader. Now, this is being deprecated in 2.0. Why? Because XFA, almost the only company that supported XFA was Adobe itself. So you needed Adobe Reader. If you have an XFA form and you open it in preview, if you open it in a browser like where you have Chrome Viewer or PDF.js, you don't see your document. And so XFA technology is being abandoned. And you see that Johannes, in his talk, he used HTML. And so that's the 3 major ways to create a PDF: from scratch programmatically, using an existing template, or by converting HTML and CSS to PDF. Why HTML to PDF? Because everyone knows HTML and everyone knows CSS. Well, that's maybe a generalization, but it's much easier than the previous options. And why would you create a template in another proprietary format? Just create the content in HTML, convert to PDF with PDF HTML. If you then need to change, like move an image half a centimeter to the right, you just have to change the CSS. No programmer is needed. You don't need to change your source code. So I'm going to give you some examples. Here we have a very simple HTML with italic and font size that we change. And we use one line, and I'm going to just go to the code to, where is my, sorry, I had this open. So we go to the source code. This is a source code. We have a no CSS HTML. And let's see, we have, we have the HTML here. So this is what it looks like in HTML. And then we run the code, run as Java application, and then somewhere in another directory, in this directory, we had, so this is created now, yeah, I'm in another time zone. I'm still in Korean time zone. And so when we open this PDF, we see that the HTML was converted in PDF with italic and with the link and with the image on the as a floating image on the right. So small changes. Instead of using italic, we use div style font style is italic. We don't use font, but div font size is 0.8 em, and we define the width of the image in CSS, inline CSS. Again, we don't need to change the code. It's exactly the same code, and we get our HTML that is converted to PDF. Now, we can move the CSS to a style object in the header. No, we no longer have inline CSS. We just say IMDb, well, font size, description. We have a font family that has changed. And for the link, we changed the color. So very simple. We have our HTML. We have our PDF. And then it's also possible, of course, to refer to an external CSS. So this isn't a separate file, a CSS file. No longer we have the definitions in the header. Still exact the same code, one line, HTML convert to PDF. We have the source, we have the destination, and now I changed the color into green here, for instance. So you can see the code that is needed is really, it's a low threshold to use it. And if you want to change something, like change the color of a link, no programming is needed. It's just a matter of changing the CSS. This is, so Chanpreet also gave you an example of events, so page events. If you have, for instance, our HTML that we convert to PDF, and you have an existing PDF that is a background, you can say, well, I'm going to convert the HTML to PDF, and every time a page is created, I'm going to add this background. The code is a little bit more, there's a little bit more code here. We implement an iEvent handler, and we say we have a PDF object stationery, that's the background. We read this stationery, so every time a new page is created, we take that stationery and we add this as an X object to the page. And so the result is that we can, and so this is convert to PDF. You have the writer, you have the document, you define the background, the handler, you say add event handler, every time you start a page, execute this event, and then you need to, we have converter properties, so we create new converter properties. We say, here we define an absolute path. So the code gets a little bit longer, but not substantially longer. It's just a matter of adding the correct properties and adding the correct handlers. And so a use case is invoices. We have a customer in Belgium. Their business is still old school. They have a lot of customers who want to print invoices and send these invoices to the customers. And so they don't print the invoices themselves. They use our customer as their publishing partner. So what does this publishing partner do? They ask for from every customer, they ask the raw data that can be converted into simple HTML. So simple HTML, black text on a white background. And very simple tables. They ask the customer to provide the CSS to apply the styles. Like the table, the header cells need to have a green background, and the font color of the header cells needs to be white. And then they ask a customer-provided PDF as company stationery. So the letterhead with the logo and the footer with the phone numbers and the address, that is a PDF that they ask. And so this printing company uses iText to merge all these things, the data with the CSS that is applied to the data and the background. And so every time they sign up a new customer, they don't need to program anything. They just ask for these resources, which are easily provided, and they can start creating a lot of invoices, and then they print them, put them in envelopes, and they got sent. Another customer of ours, so that customer is called De Persgroep. It's a Dutch name. Another company uses iText to do this digitally. That's Unified Post. They serve as like the post office for invoices, and they have already moved from paper to digital completely. Now, this morning when I talked about standards, I talked about the fact that HTML, when creating an HTML and CSS file, you don't always know how it will be viewed. Could be viewed in a browser, could be viewed on a phone, could be viewed on a tablet, maybe on a watch. And with HTML, you have the advantage that the content can be rendered differently based on the device. So you see the red part is a header, and then you have a body with a side pane on every side. And if you watch the page, if you look at the page in a browser, that's how things are organized. If you have the same web page, because the page is made responsive, if you have the same page and you watch it on a tablet, could be that the header is still in place and the left pane is still in place, but the right pane goes to the bottom. And on a phone, could be that both side panes are added on are rendered on a different page. So most of the times, navigation, for instance, or ease of use, or maybe here you have several columns and here it's all in one column. That's the advantage that HTML has over PDF. Also, if you change the orientation, sometimes the rendering can be changed. And these changes happen based on media queries, like what is the available width that you have? Are you going to print it? So, or is it on screen that you render? So this is an advantage of HTML. Now, how are we doing this? Well, this is an example HTML, and when we render it, we can see it in a different way. So let me just show you the original PDF. The original HTML, sorry. Let's go to responsive. So this is the original, and I'm going to put this here. No, this is not the original. What's happened? This is the original HTML, and when I make this smaller, you see the left pane moved, and now when I make it even more smaller, you see that the right pane moved underneath and the left pane moved on top of it. So this is what happens if you have responsive HTML. How is this achieved? Well, we achieve this through media queries in CSS, where we say for mobile we use this configuration, for a tablet we use this, and for a desktop we use this. So this is how it works in HTML. But now, how do we solve this problem for PDF? This is a repeat of a slide that I showed this morning. So you see, if you watch a PDF, look at the PDF on a cell phone, you only see part of it. Or if you want to have the complete PDF on your cell phone, the font is almost unreadable. And so something we want to achieve is that depending on the media query that you pass, that the organization of the content is different. So how do we do that? Well, here I have different page sizes, like page size A4, but rotated, so in landscape. A page size that is has a custom width, 720, and that has the height of an A4 page, and then a page with the width of an A5 and the height of an A4. We loop over all these page sizes, so we are going to create 3 PDFs. We have 3 page sizes, and we create PDF 3 times. So again, we create a PDF writer, we create a PDF document. We say, well, let's create tagged PDF, and let's set the default page size to one of these sizes. So we pass the size as a parameter. Now, again, we have converter properties. We define the base URI so that iText knows where to find the external CSS. And we define a media description where we say, well, the new media description is we are going to create a PDF that has to be viewed on a screen. And we are going to set the width of the screen to a size that corresponds with the page size. And then we add the media device description to the media description. We are also creating an acroform, by the way. And so now we are going to call the convert to PDF with the input stream, convert to a PDF document, and we pass these properties. Now, if I run this example, you still see that. Let me see how that I can abandon this one. Okay, so you see here responsive 1, alt, and 2 and 3. I'm going to run the example, so media query. Where is media query? Here. So this is the code that you saw in the slide. And now when I run this run as Java application, you will see that 3 new files are created. Responsive 1. Responsive 1, if it wants to open. Okay, responsive 1 is the landscape version. And you see a form has been created because I had some form fields. Responsive 2 is the custom-sized one with 720 user units as width. And you see this is organized differently. And then we have the one that was really narrow. This one has been created where, again, you have the other version. So this is something that can be used if you know on which device that the PDF is going to be viewed. You can use the identical HTML, and depending on the media query on the fly, you could use the same source and use a media query to create a customized PDF. Now, this is a step towards responsive PDF. In responsive PDF, one would create these 3 versions and bundle them in one PDF, and then either serve this PDF straight to the end user, so that the end user, when he opens it, the media query goes to the viewer, and the viewer selects the PDF that is best viewed. The other option is that you have the PDF pre-canned on the server, and then when the end user says, I want to see that PDF, that on the server, you get the media query from the client, and you select that PDF in the bundled PDF, in the responsive PDF that is best suited for the end user. Now, from current slide. Here I have an HTML diploma, and I have introduced some tags that don't exist in HTML. So this certifies that student John Doe, and so on, and then it has a tag date. So these tags don't exist in HTML, and so when you render this in a browser, it says John Doe and it says unknown. Now, this could be used as a template where you would say, well, I'm going to look for the student tag, I'm going to replace the student tag by a real name, and I'm going to replace the date tag by a real date. And that's actually what we are going to do. So here we have converter properties, and iText has a tag worker factory. The tag worker factory will say, well, a div tag in HTML corresponds with a paragraph object in iText. An A tag corresponds with a link. And we are going to use the default tag worker factory so that the HTML is rendered correctly, but we are going to extend it. We are going to say, if you have a student tag, well, that's like a span, like the span tag in an HTML, and you have to process the content, and instead of the real content, John Doe, replace it with the name of someone. Here it's hard-coded, but obviously you would use a database query to have a name. If we have the date tag, well, replace it with the current date. So new date will give you the date, today's date, and then to string. And so this is an extended tag worker factory. Again, we convert to PDF, input, output, converter properties. And what will happen is that if you don't add these things. So let me just run it. Let me give you the live demo. So we have diploma. And suppose that I don't define these properties. So I'm going to make all this disappear. So that's gone. So now when I do convert to PDF, run as Java application, what is the result? Diploma. This certifies that John Doe and the date is unknown. So that's not good. So we are going to place this back here. The tag worker factory. So now we will replace the content. Have I saved it? Yeah. Run as Java application hub. And we have diploma. And now we see this certifies that Bruno Louagie and then today's date and the time that it is in South Korea right now. So this is a very powerful thing if you have templates where you can use HTML and create your own custom tags. But you see, there were some errors there. And what were the errors about? Well, we didn't provide a CSS applier. So we said we have overridden the tags, but we didn't override the CSS. And so there's a more complex example where we have a QR code tag, a QR code tag CSS supplier, a QR code tag worker, and a QR code tag worker factory. And in this more complex example, we, let me see, where is my mouse? Here. In this more complex example, we will say, well, we not only add a new tag worker factory to the properties, but we're also going to add a CSS applier factory. And this will make this kind of error disappear. Now, what is the QR code example? The QR code example is not just about replacing text. So here we replace text, but is about replacing text with a graphical object. So here we have a tag QR. That tag doesn't exist in HTML. And the text says, with great power comes great current squared times resistance. And instead of this text, you see that text as a type of QR code, as a barcode. And so this is very powerful if you have, you can really, that's the power of the low-level implementation. You can really fine-tune and create your own objects in HTML. Now, iText Ditto goes one step further. It's not released yet, but in a couple of months, you will give access to early adopters. Here, we have an in-browser, so Ditto is Design Interactive Templates Online. We will have a SaaS application that allows you to have data sources, like you connect to a database and you have an invoice date, an identifier, payment. That's your structure. That's whatever you have in your database. And you will be able to drag and drop properties like text, image, and so on, and create a template like with these placeholders like invoice date, customer name, customer address, postal code. And so you will have, so I started by saying everyone knows HTML and CSS, but still it's complicated to create this manually. So we are going to provide a designer that allows you to create this HTML and CSS in a WYSIWYG. So what you see is what you get. And then, so when you have created the template, so Tyrion was the code name when we created it, and it will be called the Ditto designer. You design your template, and you have a template that consists of a subset of HTML, a subset of Bootstrap. Bootstrap is a CSS, like a repository of a CSS, pre-canned CSS, and you will store your data connections. And then you can, for instance, say, well, I'm going to serve this template as HTML to my users. So the Ditto server will have this template and serve it as an interactive form in HTML5 to the end user so that an end user can add data. That's the thing that we are going to do last. So this is not implemented. This is scheduled to be released in April, May next year. What we are working on now, and one of the first things that is going to be released is, well, we are going to use the template, the HTML and CSS. We are going to inject data from an SQL query, JSON data, XML, and we are going to merge the HTML, the CSS with the data into one HTML CSS file, and then we are going to convert with PDF HTML to PDF. And this PDF, since it's HTML, HTML is structured, it can be PDF UA, so it can be accessible, it can be PDF A, or it can be regular PDF. That's up to you to decide. So what we will have is, you have your template, like with tags saying name, address, invoice items, and so on. Then you will be able to present this as a form, where you will have form fields where a user can enter his name, his address, and maybe add invoice lines. That's HTML5. That's for data gathering. And then this will be, if you have data and the template, you can convert it to an HTML file. So not in different pages, but just one HTML stream. And then you will be able to convert this HTML to PDF, where you have page 1 and page 2 with the repeating headers. So all of this will be more in a user-friendly way. So this morning, Shanpreet showed you how you would code this to repeat these headers. But with iText Ditto, you will be able to use a WYSIWYG to define this, and then with HTML to PDF conversion, you get all of this out of the box without too much coding work. So we were a little bit behind, so I went a little bit faster. Do I switch to digital signatures now? Okay, digital signatures. Okay, now we start the afternoon session. Slideshow from beginning. Okay. So digital signatures in PDF. I'm going to go over the basic concepts of digital signing, apply it to PDF, show you some architectures, server-side versus client-side signing, digital signatures in a workflow, long-term validation, and then how blockchain made me love everything I hate about digital signatures. The basic concepts, well, they consist of, we will use hashing algorithms, we will use encryption algorithms, we will use certificate authorities, and the combination of these three will give us digital signatures. This morning I explained the goals. We want the assurance that the document hasn't been changed somewhere in the workflow. We want the assurance that the author of the document is who we think it is and not someone impersonating that guy. And we want the assurance that the person who signed can't deny that he signed. Now, hashing, how does hashing come into play? Well, back in the old days, for instance, say that a university gives every student a document with his grade, and this student then has to use this document at another university, for instance, to enroll. And he has to prove that his grades are genuine. So what the university could do, the university could say, we are going to put all these grades on a server so that other universities can check if this is genuine. But then that's a big privacy issue, because students don't want their data just thrown online. They don't want you to see that they only passed like I did, because I never had a high degree in the university. But still, they want to provide a means for others to check if the document, if the information is correct. So what the university can do is they can take all these documents with the grades of all the students, add an ID, and hash them. Hashing is you take the document and you reduce it to a fixed size string like AF1B and so on. And this string every time you take the same document and you use the same hashing algorithm, you will always end up with the same string, but you can never go from that string to the original document. So somebody who has this information can never retrieve the grade of the student. So the university could say, well, we have all these documents that we have sent out to the students, and we put the hashes of all these documents online. So when a student has the document, goes to another university and says, this is genuine, that other university can hash the document, will end up with this, and then compare both hashes. Now, if a student goes to university, the university takes the hash, and the hash is different, then the university knows that the student has forged his document. So hashing algorithms, there are different types, and this morning I talked about Shattered, the fact that SHA-1 is broken, and on Shattered.io you can find more information. The second concept is encryption. So encryption is about going from data that everyone can read to something that is protected. How are we going to use this? Well, we are going to use asymmetric keys. You can make two keys, like when you have a key for your door, you have one key to open the door, and you use the same key to close the door. Well, here in this context, we have asymmetric keys in the sense that you have a public key, the green one, and you have a private key, the red one. The private key is something that you keep private. In Belgium, we have an EID, so we have an identity card like this. Just a moment. I gave my EID to get my pass to get in. So we have an EID, and on this EID, there's a private key that cannot be extracted. And I can give everyone my private key, and if someone wants to send me a document that only I can see, that person who wants to share that document with me, I can give that person my public key. That person will encrypt the document with my public key. And then he can put this document online. Everyone can download it, but only I can decrypt it because only I have the corresponding private key. And so that's the concept of encryption with a public and a private key. Digital signing is just the other way around. We have a document, and we don't want to protect it. Everyone can see what's in the document, but we want to make sure that everyone knows that we created the document. So what we are going to do is, we could say, well, we take the document, we take our private key, only I have access to my private key, I encrypt the document with my private key, and then everyone can decrypt it with my public key, and because people can decrypt it with my public key, they know that I was the one who encrypted it. So if we combine this, now you will never encrypt a full document here for signing. You will never encrypt a full document with a private key because the file size will be huge. What we do with digital signatures is we encrypt a hash, but that's later. So some name dropping, all of these things are described in standards. You have a lot of PKCS standards, public key cryptography standards. You have some FIPS standards, and you have ETSI that also has created some standards. Concept 3 is certificate authorities. So suppose that I don't know Sujira, and we have to exchange something. So I could give my public key to Sujira, but yeah, I could create a public and private key and say, well, I'm not Bruno Louagie, but I'm Shanpreet, and I'm going to fake the fact that I'm Shanpreet. Now, how do we solve this problem? Well, by involving a third party. So, for instance, I'm Bruno, I don't know Sujira, but I know Johannes. And Johannes knows Sujira. So Johannes could be the intermediary saying, well, Sujira, you don't know Bruno, but I know Bruno, and I testify that Bruno is who he says he is. That's more or less the concept of certificate authorities. You have Alice and Bob, they don't know each other, but in between they have Trent, and Trent knows both of them, and so they can trust each other. That's how a CA works, a certificate authority. They will, through the concept of signing public keys, they will establish this level of trust. For instance, in Global Sign, they used to use a root certificate from Adobe, and then they created their own certificate based on that root certificate. They used that intermediate certificate to create certificates for hardware, and then they used other certificates based on this chain to create certificates for these keys. And I think that Johannes will show you an example of using this type of key. Now, an example, how does this work? Well, if you open a signed document in PDF, here you see the Adobe Root CA was used to sign the Global Sign Primary certificate, was used to sign the Global Sign certificate, was used to sign my certificate. And so because of this tree, because of the fact that this tree goes back to the Adobe Root certificate, Adobe Reader knows that my signature is trusted, so I have a green check mark. So this is concept 3. And if we know, if we now combine all of this, we have the concept of digital signatures. The producer of a document provides the data as is, let's say A, provides a hash of the data, encrypted using a private key, let's say B, and provides the public key. Someone who receives these 3 things, the data, the encrypted hash, and the public key, can create a hash from the data, hash 1, can decrypt the hash B using the public key, hash 2, and if hash 1 equals hash 2, then the document is okay, and then the signature is valid. Are the goals met? Yes. Integrity, hashes are identical. Authenticity, yes, the identity is stored in the public key signed by the CA, and you can even add a timestamp. No repudiation, well, if the hash can be decrypted with the public key, the document was signed with the corresponding private key. I cannot say I didn't sign this document without saying, well, I lost my private key, and losing your private key is like something that is not done. For instance, my EID, if I lose my EID, I go to the police, and the police immediately revokes my certificate so that someone else cannot use it. There are some differences between Europe and the US. In the US, we make a distinction. We say electronic signatures don't necessarily involve PKI. There's an e-sign law by Clinton that says, well, you can also have an image of a signature along with an audit trail, like this person signed this document from this IP address, logged in as this person on this date. And so if you have an audit trail, you have an electronic signature. And in the US, they only talk about digital signatures when PKI, so the public and private key infrastructure, is involved. In Europe, we speak of electronic signatures as a synonym of digital signatures, and so all the laws and regulations take this wording. There's no distinction between both, and that often leads to confusion. So I always speak of digital signatures, and I hardly ever speak of electronic signatures, because in this case that's the most accurate. So applied to PDF, you have the standard that I discussed this morning, and a PDF file. Shanpreet showed you a PDF file in Notepad++. You see it starts with %PDF, it ends with %% end of file, and you have all these bytes, and you have a hole. And so all the bytes, except for the digital signature, those are hashed and signed and put in an envelope in this part that is called the digital signature. So you have an object, and that object is it's a dictionary of type signature, and the contents are the digital signature. So there are no bytes in the PDF that aren't covered other than the PDF signatures. There's an asterisk here, because in ISO 30001, this was not true. ISO 30002 and the ETSI PADES standards make this mandatory, because it was possible to forge documents if you left some holes in the PDF. The digital signature isn't part of the byte range. That's what is shown here. The red part isn't hashed and signed, because that's the actual signature. Now, the concept to initial a document doesn't exist. You sign the complete document at once, not on a page-per-page basis. This was, for instance, in France a problem, because in France they had a law that said that every page needs to have an initial. You need a small signature on every page. And in PDF, you sign the whole document or you don't sign it. So that's one thing that conceptually isn't possible in PDF, signing every different page. I said that the signature is stored in the document, can be an advantage, can be a disadvantage. Now, what's inside the PDF signature? ISO 32000 says says the minimum requirements is that you have the signed message digest and the certificate that was used, the public certificate that can be used to decrypt this. But best practices, so in ISO language, shall is, you really need this, should is, you should have this, but if it isn't there, you're not in. So a shall, if you say it shall have the signed message digest and it shall have the certificate, and it's not there, you're in violation with the spec. If it says you should have the certificate chain, you should have the revocation information, you should have the timestamp. If you don't have these, you're not in violation with the PDF specification, but it's better to have these anyway. But there are some downsides. You need a certificate authority, and that can be expensive because they charge money for giving you a certificate, and you may need a timestamp authority, and that's also expensive. So let's look at some architectures. Server-side signing. So on the server, this is an image of an HSM. An HSM is something that you have in a data center, and it has some slots, and on every slot you can have a private key. The private key cannot be extracted, because if you could steal the private key without stealing this, then there's a security risk there. And you have an application that, like, for instance, an iText-based application or whatever signing application that you have, that takes the PDF, that creates this construction, this dictionary, and then the actual signing happens on the device. So on this device, you send bytes, you send the blue part, you send everything that is here to this machine. What do you get back? You get a signed message digest back that is then packaged and put into the PDF. Now, where do you see this? Well, company signatures like invoices. We have a car manufacturer that every invoice needed to be signed by a director manually, and so they switched to signing on a server with like the brand name of the car. So they had a certificate, a company certificate, and so that's much easier to. That's a huge save of time when you can do this. Signing services in the cloud, like DocuSign, also do it this way. So in Europe, when you sign a contract, you have to do this personally with your personal private key. In the US, you don't have to do that. An audit trail is sufficient. So what happens is people become a customer of DocuSign. DocuSign keeps the audit trail, and DocuSign signs with the DocuSign private key. And that's so here you have security management responsibilities, like the car manufacturer who signs his invoices has to make sure that his server is not hacked, because otherwise everyone could sign in the name of this manufacturer. Client-side signing, you have like this is a picture of my EID. This is my identity card. So the signing happens on this chip, or you have a SafeNet USB dongle, and then the signing happens on a small smart card inside that dongle, and you have the application on the client side with the signing that happens on the device. Use cases are like in Acrobat, you can sign, or homemade applications using iText. In a web context, well, the PDF software runs on the client, so nothing happens on the server. Java Web Start could be a way, so Java Web Start application to sign. Access to the token or smart card can be done through the Microsoft cryptography API. So in that case, you hand over the responsibility for signing to your operating system. PKC as 11 is a standard that is implemented in a lot of programming languages, so that's a way to sign. Or you can write a custom smart card library. That's what I did for fun. You have the ISO standard for smart cards, and then you just implement that standard. There's a limitation here. Most of these devices only allow you to make one signature a second. Why is this? Well, this is not as expensive as an HSM, and the vendor saw that people were using this on the server side, and like an HSM can sign thousands of documents a second, and to avoid abuse of these small dongles, they limited this to one signature a second. Security, well, the user has the smart card and the PIN, or the USB token and the passphrase, and so as long as he has the physical thing, the card or the USB token, he has his private key. And so a third architecture is deferred signing. Maybe you don't want all the heavy lifting, all the CPU on the client. In this case, you could prepare the PDF on the server side. So prepare all the complete structure of the PDF. Then send the bytes to the client. Use an app that talks to your device and then sign on the device and communicate between the server and the client. So the processing power is needed on the server. That's where all the PDF manipulation happens, but the signing still happens on the client. What is this for? Well, signing on an iPad or a tablet. The app on the so a tablet or a phone doesn't have that much processing power. You don't, for instance, you don't want to download iText on every client's phone. So, but you can create an app that has a low footprint. And it's easy to integrate in a document management system. So you have the document that never leaves the document management system, but you can still sign on the client. An example is EasySign. That's a product of a company called CITES. They keep the document on the server, but the signing happens on the client. There's a disadvantage, at most one signature a second, but humans who sign are not that fast, so one signature a second is sufficient. But also you need to trust the server that the hash that you receive is actually a hash of the document you want to sign. For instance, you could say, I want to sign document A, but the server sends you the bytes of document B. You are never going to see the difference. And you sign document B and not document A. So that's why there are some standards in place like ASAE 3000. That's where suppliers or vendors like EasySign, like Zetes, they get audits on a regular basis. So they subscribe to a program where they are audited and they get like a label, this is a trustworthy company. Document signatures and workflow. Well, a PDF document can be signed more than once, and technically, so it has to happen sequentially, because if this document is signed by this digital signature, you cannot change any of the bytes in the blue zone. The moment you sign one of these, change one of these bytes, the signature becomes invalid. So adding an additional signature means that you have to add, that the file will grow. The more signatures will be added, the bigger the file size will get. So parallel signatures aren't supported. Like if you have a publisher who is publishing a book by 3 authors and a book contract needs to be signed, the publisher cannot send the contract to the 3 authors, ask them to sign it, and then like consolidate the signatures. That's not possible. Because of this technical limitation, the book publisher needs to send it to author 1, he needs to sign it, then it needs to be sent to author 2, he needs to sign it, then to author 3, and he needs to sign it. So there's a sequence. You always have to sign sequentially. You can't track who already signed and who hasn't. So what happens quite often is, for instance, the document needs 5 signatures. The first person who signed has a document with 1 signature. The second one has a document with 2 signatures. And the 5th one has a document with all the signatures. And sometimes that document with all the signatures doesn't reach the first signer. And so that can be a problem too, so that not everyone has the document that is signed by everyone. So these are some disadvantages. So everything I marked in red are things I don't really like about digital signatures. The types you can have one certification signature that's like only possible for the first revision, and you can add modification detection permissions. You can say no changes are allowed. So if anyone adds extra signatures, it breaks. You can say form filling and signing is allowed. So sometimes you have a field where you have to type read and approved. That could be allowed. And then form filling, signing, and commenting is allowed. Commenting means that, for instance, you can add these little post-it annotations to a document. Changing content other than this will break the signature. Approval signatures are then all the subsequent signers. And new in PDF 2.0 is that modification detection permissions can also be added for approval signatures. That wasn't the case in the past. So there are some other icons that you can have. So these are the two different icons for certification and approval signatures. But sometimes you have the yellow triangle, and that means the signer's identity is unknown. What is missing? Well, the document has not been modified, so the integrity is okay, but we didn't use a CA that was approved by Adobe, and so Adobe can't vouch for you, can't say, well, Bruno Specimen, we don't know that guy, maybe it's a made-up person, and in this case it is. Or you can have the red cross, and the red cross is when, well, here the signer's identity is valid, so I faked this Bruno Specimen to make Adobe Reader believe that the signer identity is valid, but the document was altered or has been corrupted, so I get this red cross. And so you can have a workflow. So Alice signed with an approval signature, Bob signed with a certifying signature, Bob signed with an approval signature, and then suddenly Chuck changed something that was changed by Chuck. Alice's signature is still valid, but Bob's is made invalid. So let's go back, and then so after Carol, after Bob, Carol signs, after Carol, Dave signs, and then you can see if something changes, you can see where in the workflow something was corrupted. Now, certificates expire. So like the EID is valid for 10 years. Some of these USB tokens are valid for 3 years. So it depends. And so suppose that someone signed something in 2013 and then years go by and the certificate expires. Well, he cannot use that expired certificate anymore to sign new documents. So that's a red thing. But all the documents that he signed before are suddenly, yeah, we don't know if they are still valid. Maybe, maybe something happened here, and maybe someone stole the key, and so you cannot check if that document hasn't been forged. It's even worse. Suppose that this person has signed something in 2013, and in 2014 his key is stolen, so he revokes it. All the documents that he has signed before are suddenly, we don't know if they are genuine, because someone who stole the key can have put back his clock, set back the clock to 2013, and use the stolen key to sign. So how do we solve this? Well, you have something called certificate revocation lists, and something called the online certification status protocol, which, like the certificate revocation list, is a list of all the keys that were revoked. So people who had their keys stolen tell their CA, and then the CA lists that key as stolen. And you can add certificate revocation information inside the PDF to make sure that if your key is stolen, that the world knows that your key is stolen. But that doesn't solve this problem. What we want is that a document that is signed in 2013, that it's still valid in 2015, even if the key is revoked. How are we going to do that? Well, we are going to introduce another authority, a timestamp authority. And a timestamp authority, what will happen is you take your signed hash and you send it to a timestamp server, and the timestamp server will sign it and give you the signed hash back. So it's the hash is signed twice, once with your private key, once with the private key of the timestamp authority. And this, because of this, you can have you can assure that a document that was signed in 2013, if it has a timestamp that says 2013, then the signature remains valid even if the certificate was revoked after that date. Now, what to do when there's no CRL, there's no OCSP, there's no timestamp in your document? And what to do if the certificate is about to expire in your document? Or if a hashing and encryption algorithm is about to be deprecated? Like, what can you do if you have a document that was signed with a SHA-1 algorithm, and suddenly NIST tells you the SHA-1 algorithm is flawed. How do you fix that? Well, you can fix that so if information is missing, you can add that information in a document security store. So you will expand the PDF with information, validation-related information like certificate, OCSPs, CRLs. So that's one way to add. So this document only contains the minimum requirements, the shalls, the signed message digest and the certificate. You can extend this with more information. And you can ask a timestamp authority to add an extra signature, a document timestamp signature. So now you have, for instance here, the signature by the person who signed it, but you add an extra signature that is signed with the certificate, with the private key of a timestamp authority. And so this certificate, a timestamp authority has a certificate that expires too. This expires, and so you have to repeat this every time before this signature expires. And that's also a difficult thing. From a technical point of view, this looks okay. But to keep every signed document alive, to make sure that the signatures are valid not only 3 years, not only 10 years, but that the signature is valid for 75 years, that's the whole infrastructure. And that can be very expensive. Suppose that you have 1 million of documents, that means that you have to do all of this 1 million times, many times again, over and over again. So what you could do, and that's standard anymore, not standard, but that's a proposal that the industry is making, and I wrote a couple of patents in this on this subject. So you could use blockchain. Now, for those who don't know blockchain is a distributed system, and you have, for instance, a block, and you add different records to a block, and you take a hash of all these records in a block, and you store this hash with the block. So you have a set of records. And then you create a new block where you add new records, and you create a hash that is based on the hash of the previous block, along with hashes of the records in this new block. And so you create a complete chain of blocks, so with small pieces of data in every block. Now, this is a distributed system. So, for instance, you have different nodes, and all the nodes have all these blocks. So the database is in every node. So, for instance, this could be a bank, this could be a company with a CRM, this could be another company, this could be an individual. They all have a copy of this database with these small records. Now, this node, like I create some new data, and I propagate that data. I propagate that data to the nodes nearby, to all the nodes, and every of these nodes is going to make a new block with all the new records. Now, this has been made very difficult. To add a new block, a puzzle needs to be solved, and to solve this puzzle, you need a lot of computer processing. So you need a supercomputer. But because of all the nodes looking for a solution to add a new block simultaneously, the puzzle is made in such a way that a new block can be added in 10 minutes. And so, for instance, all these nodes have worked together to add a new block, and this node has solved the puzzle first. Well, this node will add a new block, will propagate a new block, and so this block will go into the blockchain. Now, the proof of so this one has solved the puzzle, and the block is added and propagated. So every of these nodes has the same data. Now, if two nodes create a block simultaneously, it's the one that results in the longest chain that is valid. So in this case, these two will die, these two branches will die. Now, what is the advantage of this? Because of this structure, if you have some information here, You know when this was added because there's a timestamp in every block, but this cannot be forged. Why can this not be forged? Because this thing was hashed, and you have the hash here, and then that hash was used to create this hash, to create this hash, to create this hash. So if someone forges this record, the complete chain gets invalid. So, and because of the fact that this chain is propagated in every node, it's nearly impossible. It's impossible to forge something. Now, how does this work in the context of PDF? I'm going to, well, this is how you could establish a web of trust. I explained this when I talked about CAs, but we are going to do this without a central authority. We will create relationships between nodes where we say this node trusts this node, trusts this node, trusts this node, so that node can trust that node. And if we have sufficient, so this is only one link, but if we have sufficient paths from one node to another, we have a web of trust, and we can establish some authenticity and some identity. We can make sure that everyone in the node is known. Now, blockchain for documents. What could we store in a record? Well, we could create a record where we store a document ID, like the ID of the document is ABCDF, ABCDF. Why are these two parts of the ID identical? Well, in PDF 2.0, an ID for a PDF has been made mandatory, and the spec says that when you create a new document, so the document is created from scratch, it consists of two IDs that are identical. When the document is altered, like you have a form and it's filled out, or you have a PDF and you add a watermark, the first part of the document ID needs to remain identical, but the second part needs to be changed. So when you see a document with an ID that consists of two equal parts, it's the original document. When you see a document where the ID has two different parts, that's a document that was somewhere in the workflow changed. So we store the document ID in a record, in a blockchain record, and we store a signed document hash along with the certificate of the signer and maybe a compressed property list. And so instead of, so this is what we usually store inside the PDF, but instead of storing this inside the PDF, we store it in the blockchain. And so the advantage, that's the explanation of PDF 2.0, where we say that the file identifiers are mandatory. But of course, if company A creates a PDF and company B creates a PDF, how do they know from each other that the ID is identical? Well, usually an ID is created through hashing, and the chance that two hashes are identical is very low, but a very low chance means that it is possible. So what we could do is we could use blockchain and say, well, I'm creating a record with an ID of where I want to register a PDF, and I'm going to look in the blockchain, so everyone has a copy of that blockchain. I'm going to see if there's already a document in the blockchain that has this ID. If the ID is not unique, well, we create a new ID for our PDF. If it is unique, we propagate it. So this is a way, by storing the IDs of every document that is created in the blockchain, this is a way to make sure that the ID is unique. Okay, that's secondary. But what are the use cases? Well, in Luxembourg, there's a big depot with works of art, like paintings and silverware and whatever. Why Luxembourg? Because if you purchase, or if you sell a work of art in Luxembourg, you don't need to pay taxes. You only need to pay taxes the moment the work of art crosses the border. So what happens is people invest in artworks that are in the depot in Luxembourg as an investment, and they don't pay taxes. And so when the value increases, they resell it. And as long as the work of art has never crossed the border, there's no taxes involved. But of course, how do you know that the work of art is genuine? Well, you need a certificate. And the certificate, like here, we have a certificate of a Picasso. You could store this certificate in the blockchain and say, well, the ID is AAA, and as a property, so the gallery owner, the broker who sold the work of art is Alice. She signed that certificate, and the owner of the work of art is John Doe. Now, Chuck could pretend to be John Doe, and he could offer a fake Picasso through another broker. And he has done a bad job because he made a certificate with the image in reverse, in the mirrored image. And so he offers this certificate and he says, well, look, I want to sell this work of art. And he uses Bob as broker, and Bob says, well, the certificate, you gave me a certificate, but I cannot find this certificate on the blockchain. So your certificate has ID BBB, and I think you are trying to sell me something that isn't real. I think you have sold me, you have given me a fake certificate. So the first attempt to offer a forged painting with a fake certificate fails because the certificate can't be found on the chain. Then Chuck runs away and he says, I'm going to be a little bit smarter and I'm going to again offer a fake Picasso, but I'm going to look on the blockchain and I'm going to use an ID that exists. And now, one of the reasons why we only store a hash is with the hash nobody knows that it's a Picasso. So here Chuck was really in luck. He guessed that the Picasso had this ID, but usually people don't want you to know what they own. So the hash, that's like really improbable that this happened. But he has a document with the right ID, but he forged the certificate. So when Bob checks, he finds this document, but when he compares the hashes, he says, well, I think this is forged because I find this document registered on the blockchain, but there's a difference in the hashes, so it's fake. So the second attempt to offer a forged painting with a fake certificate fails because the hashes don't correspond. So Chuck runs away again and he says, well, no, I'm going to be really smart. I'm going to steal the original certificate. So he has the original certificate. He has it obtained by hacking John Doe. And he goes to his broker and he says, well, look, I have this real certificate and I want you to register it on the blockchain and put the painting on the name of Richard Rowe. So Bob checks and says, okay, AAA, the hash computes, so I'm adding this block. So has the crime been successful? Well, no. Well, yeah, history shows that John Doe owned an object of art from that point to that point, and that Richard Rowe is the current owner. Has Chuck been successful? Well, no, he hasn't, because there could be another party involved, Carol. Carol has an insurance service, and Carol manages all the assets of John Doe. And Carol notices, so Carol monitors all the documents that are related to this painting and other assets owned by John Doe. And Carol notices a pending sale of a Picasso. And so, of course, Bob has been smart, and he has said, well, give me the, so I won't sell it to, I won't sell this object right away. I'll keep the money in escrow. And so Alice sees a change in ownership on the blockchain, and she alerts John and Bob. She says, John, I think that one of your assets has been sold. Is this correct? Are you no longer the owner? And John says, no, I'm still the owner of this asset. So Carol can immediately add a new block, overruling the block by Bob that was created by Chuck Go. So this is a way that you could use blockchain to register assets. There's a real-world implementation in the harbor of Antwerp where they are introducing this for ownership of containers. So the harbor of Antwerp works together with the harbor of Singapore. Containers leave the harbor of Singapore, and then they end up in Antwerp in a big container lot. A driver goes with a truck to get the container, but because of the fact that there are many parties involved between Singapore and Antwerp, sometimes the code gets stolen, the code to get the container. And so you never know in which station the code got lost. And so by always attributing the container to one station that is responsible, and the end station is the driver, you can avoid that people kind of steal assets. Supply chain. Suppose that Alice is a customer and she wants to buy something from Bob. She creates a document, 1234, 1234, and she registers this document on the blockchain with the status quote request. Bob receives the document through mail from Alice, and he can check if this document is genuine by looking, do I find this document on the blockchain? And Bob adds some information, and he creates a quote, puts it on the blockchain, sends the quote to Alice, and Alice can see, is this quote genuine? Then Alice can say, well, the quote, I accept it, and I'm putting OK on the document, register it on the blockchain, and this way, Bob can also see, okay, this document used to be a quote in my CRM, and so the CRM always receives all the blocks. So the CRM of Bob receives this block, looks at all the IDs, no document is important for me, all the IDs, no document is important for me, and then suddenly he sees this document, 1234, I have a document that is similar. So 1234, 5, 6, 7, 8 has a new version, 1234 ABC. So his CRM detects there's a change in status of a quote that I sent. It's now in the status PO. So what is Bob going to do? He's going to ship the goods that were requested using Carol. And Carol is going to add like a shipment version of this document. And then Alice will receive the goods, say, I accept them, and then at some point the bank will receive payment from Alice and will register a paid invoice. So in this context, blockchain is used in a workflow. So you have one document that is used in different statuses, like a quote request, quote, PO, shipment, accepted, paid. And because of the fact that this document is registered in different phases of the sale, every system, an ERP system, a document management system, a CRM, can retrieve the current status of the document in real time. A last example is long-term validation. So I explained how long-term validation works in PDF. So you always have to extend the PDF with a new document security store, with a new timestamp signature. Well, here we could solve this by saying, Alice, she owes Bob money, so she writes an IOU. I owe you $1,000, for instance, and they both register that document on the blockchain using a hashing algorithm X. That hashing algorithm, after some time, its flaws are discovered, and Alice, if algorithm X is expired or can be broken, Alice could change the document, saying instead of I owe you $1,000, she could change it into you owe me $1,000. So what could Bob do to prevent this? Well, if a new algorithm is found, like algorithm Y is the successor of algorithm X, Bob could take the same document, ABC123, ABC123, and add a new registration of this document with a new algorithm. It would be in Alice's benefit to do the same thing, because she doesn't want Bob to register something that says, I owe you $10,000 instead of I owe you $1,000. But so you can, every time that a new algorithm is used, you can add a new record. So Bob makes it impossible for Alice to exploit flaws that are discovered in old algorithms or to take advantage of increased processing power to forge a document and calculate a matching hatch. What is a use case that one of our customers had is when rich people have a last will and testament, there's often a debate, is this testament genuine or not? What happens is the person deposits his last will and testament with a trusted party. So there's somewhere a copy of his testament that is safeguarded. Now, what you could do is, and then so when he deceases, that document needs to be fetched. What he could do is, he could use a digital document and go to a trusted party that registers this document, for instance, every 3 years. So the document is added, so a signed hash of the document is added to the blockchain every 3 years automatically. He pays a subscription to do that. And everyone has access to the blockchain, but no one knows the contents of the last will and testament. So when this person then deceases, the family can go to the notary, and the notary can have a PDF. And in this PDF, it says, my son X gets that amount, my son Y gets the house, my daughter Z gets the car. And if there's any doubt on the validity of the document, so if X says, hey, that's not the real last will and testament of my father, they can always check the blockchain, and they will always have a registration of that last will and testament in the blockchain using the latest encryption algorithms, using the latest hashing algorithms. So this is a use case of use case last will and testament. So these are some things that are being developed. With iText, it's part of our research and development, and we are working with different startups. So all the use cases that I gave you are use cases that are being developed by startups in Belgium or elsewhere in Europe. And that could solve a problem with digital signatures because it's less expensive to put in place a web of trust. You don't need a CA. For instance, one of the startups that we work with works with banks. If you have a bank account, you have to go to the bank and show your ID, and they register that. So if the bank puts that registration in the blockchain, the bank says, yeah, Bruno Louagie, we know him, so you can trust him. He's a real person. He's not a fake person. So by doing this, or a government could do that. The government could say, well, Bruno Louagie is indeed a citizen. He has gone to the city hall. He has presented himself, and we have checked his identity. So no CA needed. No timestamp authority needed because blockchain, you have inherent timestamps. And the problem of sequential signing, well, you can always check on in every moment who signed when, and there's no specific order in which that the blocks need to be added. So this could be a way to, for instance, embed something like that in every CRM, in every ERP. And so every document that goes in or goes out gets registered, and no one knows the content of the document, but everyone can check who signed when, and has this document been changed, yes or no. I don't know of any laws that already say this is legally valid, but I think that this is the direction that digital signatures is going to head in. Yeah.
Do you have to be, for yourself, do you have to be part of the blockchain?
No, so everyone can subscribe to the blockchain, and so
You have to subscribe.
You have different types. You have private blockchains, like there are companies who say, well, the blockchain is private, but you also, in this case, I would make public blockchains. It depends. If it's like a closed organization, like to exchange things intercompany worldwide, then they would close up this blockchain and use it only inside the company, and everyone has to subscribe. If it's something like universities and students, every student should be able to get access to the records that are about his documents. So they.
So you're saying that this is a private blockchain, right? Instead of the global blockchain.
You could do this on any blockchain. So that's why I said, you asked me, should you subscribe, yes or no? It depends. In a company, they could choose to make this private. But in another context, you could choose to make it public or do it on whatever blockchain.
Because the public blockchain is so huge.
Yeah, that's huge. Yeah, that's true. So that's why I say it depends. So, for instance, universities could go